Hello, in this video, we're going to cover the creation of ladder logic diagrams based on the equivalent Boolean expressions. So on the left-hand side, I have a not expression. So the way this reads is if input A is not true, then output Y is true. If input A is true, then output Y is false. So first thing we'll do is launch all of our applications. So I have RSLogic's MicroStarter Lite. I'm also running RSLogic's Emulate 500. I'll be testing on virtual I/O, not a physical PLC. And then I have RSLinks Classic Lite running in the background. So I'll create a new project and I'll just choose the MicroLogic's Series 1100 PLC. First thing we want to do always is configure the I/O so that we have the actual input and output addresses. So I'll just use the IQ16 for the input card and OB16 for the output card. And then we will go ahead and just save our project, get that out of the way, and we'll just call this logic gates. First, I'll add a negated contact to my rung. This represents input A, and the circle on this symbol represents a negated input. Another way of saying negated input is examine if open in RSLogix, or normally closed in electrical diagrams. They all mean the same thing. And then last, we'll add our output. So this is going to be tied to our first input channel on the input card, which is slot 1, channel 0. And we'll just call this input A, and the symbol will be A. And then we'll configure our output for output Y, which is going to be the first channel of our output card, which is in slot 2. And this will be channel 0 of output slot 2. And we'll call this output Y. And then the symbol will just be Y. So now we can verify our rung edits and confirm that we have 0 errors. And then we'll go online with a download to the PLC, place our PLC in run mode. And you can see that when my input is false, my output is true. Now, if I open my I1 input table, you can see that on input slot 1, channel 0, my current input status of channel 0 is false or 0. So we'll go ahead and change this to 1. And you can see that my circuit is no longer true. My output on Y is also no longer true. And the next type of gate that we're going to create is an OR gate. So the way that we create an OR gate is with a series of branches. So first we will drag a open set of contacts to our network. And then below our network, we're going to add a branch with another set of open contacts. And then last, we'll add our output. And now we're going to go through and address each one of the inputs. So I'll do input 1/0, and we'll call this input A, and this will be A. Next one will be I slot 1, channel 1, and this will be input B. And then last, we're going to have our output, which is output slot 2/0, and this will be output Y. Now we're going to verify our rung to make sure we have no errors, and then we're going to go online with the download. And we'll go ahead and save this project as logic gates. And then we're going to place the program in run mode so that we can test our changes. So now when both the inputs are false, the output is false. If I toggle input 0, our output goes true. If I also toggle input 1, our output stays true. And if I toggle output 0 to false, our output also stays true. And if I go back to both inputs being false, then our output also goes false. So this is an OR gate represented in ladder logic. Our next type of gate is an AND gate. So to create an AND gate, we're going to add a series of contacts followed by a coil, and these will be in series with each other. We'll go ahead and use the first available input for input A. Again, we'll call this input A with the symbol of A. Next, we'll add an input for input B, which is going to be on slot 1, and it will be channel 1. And we'll call this input B. And then lastly, we're going to reference our output as channel 0 of slot 2. This will be output Y. And we'll verify our rung to make sure we don't have any errors, and then we'll go online with the download. And we'll make sure our program is in run mode. And then we'll test these changes. So the expected output when both are false is false, and that matches our truth table on the left-hand side. If I toggle the input A to true, our expected output is also false according to our truth table. If I toggle A to false and B to true, we also expect an output of false. And then if I toggle both input A and input B on, our expected output is true. And lastly, the final logic gate that we're going to review in this video is going to be an exclusive OR gate. So with an exclusive OR gate, you need 4 sets of contacts, and I'll explain why. So first, we're going to add a normally open set of contacts, or examine if closed if you're using RSLogix 500. Next, we're going to add a normally open set of contacts, or examine if open. And then we're going to add a branch and add the same set of contacts below in an inverted order. So for here, I'm going to add an input for input A, which will be channel 0 of slot 1. This we'll call input A. Next, I'll add an input for channel B, which will be input 1, channel 1. And we'll call this input B. And then we're going to add the same inputs below using the negated contacts. So this will be input 1, 0 for input A, and then input 1, dash 1 for input B. And at the end, we want to add our output for Y, and this will be channel 0 of slot 2. We'll call this output Y, and we will verify our rung to make sure we don't have any errors, and then we're going to go online with the download. And we'll just save this as untitled, and then go online, make sure we're in run mode. And so the way this should work is if both input A and input B are false, then our output is false, which is the case currently. So I'll go and open my data table, and you can see that channel 0 or input A is false. Channel 1 or input B is also false. If our input A is true and our input B is false, then our output should be true. So I'll go ahead and set input A to true, and you can see that output Y is true currently. Now, if I toggle input A to 0 and input B to true, you can see that the output of Y is also true, which is what we expect. Now, if I set both input A and input B to true, our expected output is false. And so that's why we need 4 contacts, so that we can monitor the state of the other input in series with the contact that is either true or false. That way we can verify that this rung is only true when one or the other is true, but not when both are true. Thank you for watching, and I hope this helps.